In this lesson, we are going to look at frequency tables, histograms, and frequency polygons. Our goal is to create frequency tables and graphs from a set of data. A frequency distribution is a set of intervals, whether it's in table or graph form, usually of equal width, into which raw data is organized. Each interval is associated with a frequency that indicates the number of measurements in this interval. In this first example here, we have data that represents the flow rates of the Red River from 1950 to 1999, as recorded at the Redwood Bridge in Winnipeg. We want to create a frequency table. In order to do this, we need to know what our range of data is. If we were to look through the table, we will find our largest data is 4,587, and our smallest is 159. So we need to find this range of data. It's 4,428. Frequency tables generally have between 5 and 12 intervals on them. So 5 to 12. We have a large range of data. Maybe we choose 10. 4,428, we need to be able to change that into 10 increments. So if we were to divide this by 10, we would have 442.8. Now it's nice if we can have round numbers, if at all possible, in our frequency table. So maybe we could round this to 500. So what we are going to have in our table is we are going to have frequency intervals of, I'm going to make this smaller so that we have room to draw everything here. We're going to have frequency tables of 500. So what we have is we've got from 0 to 500 is one interval. 500 to 1,000. And we need to continue these intervals until we have reached 4,587. And we needed 4,587, so we need to have one more interval on here. So these are all our intervals. So now what we're going to do is we're going to put this into a table. And this would be our first column. And what it is it's our flow rate. Now what we're going to have is we're going to have a tally. We're going to find out how many of the flow rates fall in those intervals, and then we're going to find what our frequency is for each interval. Now the other thing to keep in mind, if you notice, we end and begin with the same number in each interval. Our first interval goes to 500. Our second interval starts at 500. You need to be aware of what the frequency table uses. Some will have the first interval including the 500, and the second interval would start at 500.00001, etc. Some will have the first one going to 0 to 499, and then the second one starting at 500. The resource that we use, where your answers will come from, the 500 is included in the first interval. So we go to 500 here, whereas the next interval is going to start at 500.0001, whatever the next point would be. All right, and then the 1,000 would be found in interval 2. Interval 3 would be the next number after 1,000. So it is important to note whether the 500 is included in the first interval or the second interval. Now I've moved the table so that it is beside and we can analyze the data. So now we go through and we do a tally. We look at our flow rates and each values and we place them in the appropriate spots. So in 1950, our flow rate was 3,058. So that is in this interval. And so we go. The next one's 1,065. And then 1,008. 357. 524. 1,521. 1,974. 654. 524. 991. 1,965. 481. 1,688. 660. When we tally something, we hit 5 of one thing, we often put a line through it to show that there's 5s. It's easier to count. We can count by 5s then on our tallies. 1,002. 1,809. 2,498. 1,727. 510. 2,209. 2,280. 1,526. 1,589. 530. 2,718. 1,671. 1,807. 187. 1,750. 3,030. 881. 159. 1,458. 1,393. 1,048. 991. 1812. 2,339. 564. 1,390. 396. 280. 1,399. 946. 1121. 1877. 3,058. 4,587. 1557. And 2180. So we've tallied up all of the values. Now we find what our frequency is. There were 6 in this interval, 11, 14, or sorry, not 14 there. There were 9, 14, 5, 1, 3, 0, 0, and 1. And we have now created a frequency table from which we could then answer some questions and analyze the data. Basically what this does is it organizes the data into a table for you so you can maybe see where does most of the flow rate occur. Were there many in that high end? Are there many in the low end? You can just kind of analyze your data from here depending upon what it is that you are looking for. A histogram, the graph of a frequency distribution in which equal intervals of values are marked on a horizontal axis, and the frequencies associated with these intervals are indicated by the areas of rectangles drawn for these intervals. So if we want to create a histogram, we have our same amount of data here, but now maybe we choose to draw our histogram instead of just a frequency table. So we're going to go back and we're going to pull up our frequency table from the first example. So what we've got here is we've got our frequency table. So if we were doing a totally different question, you would have to go through and you'd have to create your frequency table to begin with before you can create your histogram. But now a histogram, what we do is we have an X and a Y axis, or a horizontal and a vertical axis. On our vertical axis, we're going to talk about our frequency, and our frequency was in the number of years. So how many years had certain flow rates, or the intervals of flow rates? So this is the number of years that the certain range occurs. And we do need to draw a scale. If we look at our frequency table, the highest we go up to is 14 in a frequency. So we need to make sure that we go that high on equal intervals. So I have my number of years. Now I put my intervals along the bottom. So from 0 to 500. And then 1,000, 1,500, because my intervals were in 500s. So I need to make sure that I have the same scale on my horizontal axes. And this is our water flow. So now what we do is we draw rectangular regions. From 0 to 500, we had a frequency of 6. So we draw in our first region, we draw a rectangle and we shade it in. So that tells us in the interval 0 to 500, this occurred 6 times. From 500 to 1,000, it occurred 11 times. So then we shade in our area. From 1,000 to 1,500, we had 9. From 1,500 to 2,000, there were 14. From 2,000 to 2,500, we had 5. From 2,500 to 3,000, there was only 1. From 3,000 to 3,500, there were 3. Then we had, the next two intervals had 0, and the last interval again had 1. So now we have drawn a histogram. It's just a different way that we can look at the data. Sometimes a visual representation is more, I guess, appealing than just the numerical representation. Some people can look at this and they can analyze different things. Maybe they can analyze trends. We're going to get into normal distribution, and histograms help us to determine if something has a normal distribution. So you have now created a histogram. A frequency polygon. This is the graph of a frequency distribution produced by joining the midpoints of the intervals using straight lines. So we're going to use our same example again, and we're going to create a frequency polygon. Now, in order to do this, it is often easiest if you first have created your histogram. You don't have to. You could set it up the same way on a table of values using your histogram if you wanted. But since we have a histogram, I'll show you how creating your polygon works. So I have copied over the histogram. Now it is the graph that joins the midpoint of your intervals. So the midpoint of 0, 500 would be 250. And then the midpoint would be 750. So basically the middle values of each of our intervals. And we can start at 0, and now we simply join the points with a straight line. So we're joining the lines, of the midpoints, and we have now created our frequency polygon. We could take away the histogram out of there, and we would just have our overlay of the line. And the nice thing about the frequency polygon is that you could compare more than one set of data on the same graph, just using different colors for the lines. The large sets of data can be difficult to interpret. Organizing the data into intervals and tabulating the frequency of data in each interval can make it easier to interpret the data and draw conclusions about how the data is distributed. And a frequency distribution is a set of intervals that can be displayed as a table, a histogram, or a frequency polygon. So some of the things that you need to keep in mind is the frequency distribution should have a minimum of 5 intervals and a maximum of 12 intervals, although really any number is possible. It's just too many or too few will result in a table or graph that may not effectively show how the data is distributed. Determining your interval width you can do by dividing your range of data and then rounding to a suitable interval width. The height of each bar in a histogram corresponds to its frequency of the interval it represents. Because the individual pieces of data are not visible in a frequency distribution, all we know is how many are in the interval. We don't know what those actual values are. The minimum and maximum values and the median cannot be determined directly. And frequency polygons serve the same purpose as a histogram. However, they are especially helpful for comparing multiple sets of data because they can be graphed on top of each other.